Alright, this is PlayDB under the hood talk. So what are the open source libraries we use? We use Common Jexl, MapDB, and Google Gson. To simplify everything, we use Apache Jexl to parse if conditions or condition statements like age is greater than 22 and name is Bob. Find all the records. So for anything that has to do with the read searching or remove replace, for any search if conditions, search conditions, we use a Apache Jexl to parse it. And then MapDB we use it for the data structures, that we use a B-tree data structure. We're planning to actually implement hash trees and other data structures into our database, but primarily we're just using the B-tree right now. It takes care of the read-write operations to disk that we don't have to do that, so we don't have to code it. MapDB takes care of all the disk operations when writing to a physical disk or a disk file, you could say, or in memory. And Google Gson for parsing, we use that for validation, to validate the JSON data if it's actually in JSON format. If not, we do not, the user is not allowed to insert it into the database. And so, yeah. And then we use the B-tree data structure for our tables. So when you create a table, this is how it's stored in a B-tree data structure. So you would say the key would be an integer, and this would be the string value. Once written in a disk, it converts into binary. And I would say all databases use the B-tree data structure. This is how it's stored. I would say our search time and our index time is not optimal like any other databases. It's at O and N time. But if you were to search with the keys, it'll be at log and N time. That's a little bit of nerd talk for you, for time complexity. All right. Next one I want to get into is the code design. So basically what's happening is when you type a command, it gets parsed, and then once it gets parsed, it gets pushed into the QE. And if you're running the play interpreter, it doesn't get executed until all the commands are read in the play file. But if you're just entering the command from the command line, immediately once it's pushed, it gets in the QE and then it gets evoked, executed. So once it gets executed, it goes into command. Depending what command object you have selected, once it's parsed, it chooses the appropriate command object. And if it's going to the database, it goes to the B-tree database access object, B-tree schema, and then it uses the data source. So command invoker and data source are singleton objects, or you could say they're singleton in a way. It's not fully singleton. And from there, you could see that the database uses from here the MapDB library, and we're kind of using inheritance or factory method to create or connect to database. So factory or builder method. And this is the disk access we have right here. Data source uses the disk access. So yeah, so anything that has to communicate with the database or the B-tree, we use the B-tree database access object, goes to B-tree schema, and then goes to the mother schema or the parent schema object, and this parent schema uses the data source. And then when you get the plain interpreter, it goes to plain interpreter. So the package 2 for the parsing, you can see here for func parser and express parser uses the Jexl library. All right, and we didn't add the Google Gson library here because it's not that, the code's not using that much code from Google. Yeah, that's pretty much works. So let's just do one quick case. So user types in read gets parsed, it gets pushed, and then it gets evoked. Once it gets evoked, the command object executes. So it goes to read goes to the B-tree database object, it reads, and then from there it goes to the schema, and the schema connects to the database source. From there, the data operations for the MapDB file is taken care in the B-tree schema. All right, that's how PlayDB works in a nutshell. I hope you guys enjoyed this video, and thank you for watching.